In this module, you will learn to derive the formula for surface area and volume of a cone. A cone is a solid with a circular base and a curved surface that tapers in a point called vertex. Next, let's see how a cone is constructed. A right-angled triangle is taken. If the triangle is quickly rotated along one of its perpendicular sides, a cone is formed. The side along which the triangle is rotated becomes the height h of the cone. The other perpendicular side becomes the base radius r of the cone. A cone has a slant height L. It is actually the hypotenuse of the right triangle. A cone is called right circular cone if its base is a circle and the line joining its vertex and the center of the base is perpendicular to the radius of the base. In this module, we will consider only right circular cones. As you can see, the difference between the height and slant height is that the height is perpendicular to the circular base of the cone, while the slant height is not. Using the Pythagoras theorem, we get the relation between L, R, and H as shown. The total surface area of a cone can be obtained by adding the curved surface area of the cone and the area of its circular base. If we cut it along its slant height, it opens up to the shape as shown here. The straight edges represent the slant height L. The curved edge represents the edge of the circular base. Hence, the length of the curved base will be equal to the circumference of the circular base of the cone, which is equal to 2 pi r, where r is the radius of the base. Now, let's divide this piece into as many triangles as possible. The curved surface area of the cone will be equal to the sum of the areas of these triangles. The area of each triangle is calculated as half base into height. Since the triangles are so tiny, the height is equal to the slant height L of the cone. Let the base of these triangles be B1, B2, B3, and so on. The total area of all the triangles can be calculated as shown here. Taking half and L as common, we get the total area of the triangles as half slant height into the sum of the bases of the triangles. Here the sum of the bases is equal to the perimeter of the circular base of the cone, which is 2 pi r. Thus, the curved surface area of a cone is equal to pi rl, where r is the base radius of the cone and L is its slant height. The area of the circular base is pi r squared. Therefore, the total surface area of the cone is pi rl plus pi r squared. Taking pi r as the common factor, the formula can be written as pi r multiplied by L plus R. Now, let's see how the volume of a cone is calculated. A hollow cylinder and 4 hollow cones are taken such that the circular base radius and the height of both the cylinder and the cone are the same. The cylinder is completely filled with liquid. On pouring the liquid into the cones, the entire content of the cylinder can be emptied in 3 cones. This means that the volume of a cylinder is equal to 3 times the volume of the cone. Since the volume of a cylinder is pi r squared h, the volume of a cone is 1/3 the volume of a cylinder. In this module, you learned that a right circular cone has a circular base and a line joining the vertex to the center of its base at a right angle. The formula for the curved surface area of a cone is pi r L. The formula for the total surface area of a cone is pi r multiplied by L plus R. The formula for the volume of a cone is 1/3 pi r squared h.